Let's just start from the very beginning. What got you into computer science?
Yeah, so growing up in South Africa, you should kind of imagine that we're like 10 years behind everyone else on technology. That's less true today than it was when I was growing up. But we always had like old computers lying around the house. But what really got me into it was when one of my best friends' brothers went off to college, and he came back. And this was when people still had textbooks, actual physical textbooks, and there was a textbook on C programming, just sort of lying around. And I was bored over the summer. The summer's in December in South Africa, so it was sort of the Christmas holidays, and picked up that book. And he also had this binder, which was a printout of something called the Anarchist's Cookbook, which had a whole bunch of really weird stuff in it. It was sort of a mixture of philosophy and how to hack into stuff on the internet, and there was a whole bunch of very unsavory stuff in there too that I don't recommend. But it just sort of felt like rebellion, and sort of which is obviously appealing to a teenager, but also just something like interesting, this kind of forbidden knowledge. And so I got really into trying to learn that stuff, and then just started hacking around on the computers we had lying around. I guess when I say the word hack, you guys should know that I don't necessarily mean breaking into like another computer. I mean like building something, maybe not for the purpose it was intended, or just trying something out with code, or the sort of original meaning of the word hacker kind of comes from that culture, rather than sort of people trying to break into computers.
So what was one thing that you built, or I guess hacked?
Yeah, so okay, yeah, one thing that we did, which is very memorable to me, but it's very dumb, was simply being able to send a message, just writing enough code to send messages from one computer to another, using like sort of the fundamentals of the TCP/IP protocol, which is the protocol underneath the internet. Just wrote a very simple little messaging app, and it's not important to anyone else, but to me it felt like magic. Somehow you could make something happen on a computer far away, and that just kind of felt like magic. Some of the other stuff we made was sort of less less kosher. Turns out you could sort of make phone calls free to international calls if you got access to a phone box, and we kind of had some instructions on how to do that. Yeah, we were still teenagers.
All this started with a book on C programming that somehow
C programming and sort of some fairly unsavory material as well. And yeah, I guess what made the other thing that kind of inspired me was The Matrix. The original film, The Matrix, came out when I was like maybe 14 or 15. And that was kind of like, oh wow, all the heroes in this are like computer programmers, and they can literally shape reality. And I think like there's some truth to how that like the world kind of played out that way over the few years after that. A lot of our reality today is shaped by people who studied and practiced computer science.
Yeah, I think, and to your point about like The Matrix, and I guess like I think for me, movies played like a big part in getting to CS, but like different movies, obviously, right? Not like The Matrix, which was like 1999. I was definitely drawn to CS because of the Marvel movies. Iron Man in particular was like huge. I mean, yeah, if you see it, you can believe it, and like to your point about making things that may not be useful, like the robots we build on the team obviously aren't going to save the world, but they're they're fun, useless bots that are
yeah, I think there's something powerful about useless things. It's play, and right. I think it's like constructive play. I'll be honest with you, when to that video you guys just showed, the robots, when you guys were like the video of the robots going and like stacking blocks and moving them around, all that was like going through my mind there was like construction, or like picking up rubble. If a building's been destroyed or something that's dangerous for humans to do, those robots, if scaled up to be like industrial kind of quality, those would be useful.
Yeah, actually, just like to talk a little bit about with the robotics competition we compete in, every year they have like a new theme, and so this year the theme is literally moving freight, like transportation. And so I guess the game developers did a good job with this one.
Yeah, it's cool.
but yeah, I think, huh. So I want to talk a bit more about like how the Matrix turned out to, I guess, become true, or not like entire. Well, no, maybe somewhat more true than some would give it credit for. What parts would you say are true?
Right. Yeah. So I do think that there's an element um, to which the reality that we have is shaped by systems, and a lot of those systems are are implemented in code, and it's people who ultimately write that code, and sometimes those systems have unintended consequences. And I think like that's really the moral and the story of the Matrix. I mean, yeah, there's the sort of virtual reality component of it, and that's all cool and great technology. But to me, the takeaway there is, hey, you build these systems, and whether they're AI or like autonomous or not, they can behave in ways we don't expect, and they can control you. There's it's kind of crazy to think, for me at least, when the first time I visited San Francisco, which was maybe 10 years ago, maybe a bit more recently than that. And my friend's like, you've got to see this thing. And she had Uber on her phone. She's actually a product manager at Uber now. And
Yeah.
she's like, watch this. And she like tapped some stuff into her phone, and a car showed up. And I was like, oh my God, what? And I'm from South Africa. It's not the safest place in the world. I'm like, and now we're gonna just get into the stranger's car. And she's like, yeah, totally. Like, of course we would. And all of the reason why you would do that is because there's this sort of safety net of systems, computer systems. Your phone can track where you are. You can get in touch with someone more or less instantaneously. So I think like that's where I think the Matrix got it right. There are people who would tell you we do live in a simulation, and that hypothesis is actually very hard to disprove. There are interpretations of quantum physics that do lend themselves to saying that we do live in a simulation. But I don't know. Maybe you guys should get a quantum physicist in to talk to you about that one. I'm a little bit out of my depth to talk about it.
I've heard people say, or at least like theorize, or just for fun say like, yeah, this is all a simulation, nothing's real. What does that actually mean though? Like, I know the metaverse is like literally you're gonna live in a simulation, but like, what would it? I guess, what does it actually mean to live in a simulation?
Right. So the idea is, it goes something like this, and I'll butcher it. But a simulation, this is something really important kind of at the intersection of physics and math, and kind of goes to a lot of what I did in college. My first job was in a nuclear reactor. And so let's talk about a simulation. You want to build a new nuclear reactor, and you want to know, how is heat going to dissipate through this nuclear reactor so it doesn't blow up? Like, are all the systems designed safely? So what do? You model it, you simulate, you have like a computer model of every part of that system, and you model how the heat flows through it and how the energy flows through the reactor. And that's a simulation, a very simple simulation of a simple system. Okay, it was pretty complicated, but you get my point.
Right.
And then you could, if your computer is powerful enough, you could simulate, like run computer models that like approximate reality more and more closely. Right. And then the philosophical magic of living in a simulation kicks in, where people say, well, if a computer that was powerful enough to run such a simulation can be conceived of, it must exist. And they say that's what the universe is. That somehow at some quantum level, there is a computer which is simulating a reality, and that's what we experience. And then it sort of goes from there. But there's a lot of resources on the internet to read about this. I think it's an interesting idea, but I wouldn't go so far as to call it science.
I think, yeah, I mean, there are like funny patterns that could end up repeating, or like could end up manifesting as true. And I think, well, call me a conspiracy theorist, I think this might be one of them. It's oddly similar, the way that computers are structured and the way that I guess the universe is structured is like, wouldn't you say it's like a little similar? I feel like.
Yeah, I think we're just sort of starting to learn about this stuff. Computers have been based on semiconductors, which are essentially hot sand, for a long time, and they are quantum mechanical in nature. Essentially, what you're doing is you're saying like something is either on or off based on the state of a transistor. But now we move into this realm of like actual quantum computing, And that sort of remains to be seen, like whether those computers can actually be useful. If they do turn out to be useful, then I think the argument that the universe is some kind of quantum simulation becomes a little bit more realistic. But that's outside of my expertise.
So then let's talk about making a simulation, or not making a simulation, but making a virtual reality. Because
Sure.
I think there's some very compelling, uh, I guess, futures that could happen if the metaverse were to like scale up. And I think, well, for one, we'd probably get rid of most of our material issues. What like immortality, I think, is like the biggest one because you don't actually need a body at that point, right? All you need is your mind.
Yeah. So I think this is an interesting idea. I don't think we have a very good understanding of like how the brain operates computationally in terms of generating thoughts and then those thoughts translating into some kind of consciousness and then that being you, your sense of self.
Yeah.
And that kind of happens at some sort of spongy biological mush level that I don't understand. One thing I know nothing about is biology. I barely did biology in high school. I got very fascinated by kind of physics and computer science and really went hard in that direction. My wife is a biologist. But yeah, I think we're a long way off from sort of uploading our consciousnesses. And I'm not sure whether that would still really be us. I think it's a pretty deep philosophical space. I think what is interesting in what you're saying is like this not having to be embodied. That's a powerful idea. I live very far away from my family. My brother lives in Australia and my parents live in South Africa, and I haven't seen them in almost 3 years. But what if I could have talking to someone over a phone or right now over a laptop screen? You are you're this big and you're square. But
Yeah.
what if you could be a hologram in the room here with me? That sense of spatial audio of like maybe 3 or 4 people hanging out and you can kind of look to the person who's speaking,
Yeah.
or maybe someone's playing some guitar while everyone's hanging out, and you being able to experience that more naturally, I think is a big step towards making people feel more connected. And I think that's in the best case where we end up in the short term on this sort of metaverse stuff.
Hmm. What would you say is the worst case then?
I kind of set myself up for that one, didn't I?
Yeah.
Yeah, worst cases are fun to think about. I think I'll give a plug for my favorite author, which is a guy called William Gibson. And he wrote a bunch of books starting in I think the 80s. And he more or less predicted most of the trends of how the internet played out because he got a few things right. Yeah, someone commented Neuromancer, totally. Neuromancer was great, and then he wrote some other books later on, which got things right about what the post 9/11 world would look like and what the targeted advertising world would look like. And he sort of writes these dystopian futures of that are sort of believable. They're not these hellscapes where no one can have a fulfilling life, but they're these worlds that are sort of filled with danger around every corner, and you kind of have to be careful about how you engage with other people and with technology. So some of the bad things that could happen would be that we have a metaverse and it makes people less social. And so they just interact with sort of AI or bots, and human sort of interaction becomes less valued. I think that would be a failure state. The idea is to connect people to each other more effectively. But if we make people more isolated, that would be bad. Another failure state, I think, would be just not getting security right. A lot of bad stuff happens on the internet. A lot of this bad stuff that happens on the internet turns into real life bad stuff. In an embodied space where you're sort of interacting with another person in a somewhat embodied way, I think there's a lot of potential for abuse or for sort of inappropriate interaction. And one thing I can tell you about my job and having sort of seen the inside of Facebook, those are really hard problems. They're really, really hard. No one wakes up in the morning and says, we're going to be evil today. but a lot of people wake up in the morning and say, man, there's a lot of hard problems we have to try and figure out. And they just really are tough. And so I think some of the bad states we can end up in are a number of different companies building a lot of technology, racing each other to release products faster and faster without really thinking of the consequences. And then probably the worst cases are unimaginable to us today. Maybe that's the scariest thing I could say.
Yeah. I also think that well, for one, if we were already not under the influence, but if AI has art, if you have you seen the social dilemma? Is it called the social? Yeah, the social dilemma.
Mhm.
Where if AI has already crossed human weakness, we wouldn't know it because it crossed human weakness, right? That's the whole point. And so, what I was thinking about, and I was talking about this to one of my friends the other day, was if the Facebook, like the is it one AI that powers all of the um I guess recommendations and personalized feeds. If there's any single AI that knows, let's say Mark Zuckerberg is the CEO of Facebook, and that he makes all the decisions, and that he would also make the decisions about whether or not that AI were to remain alive, and the AI's goal is to remain alive, then in theory, the AI could change Mark Zuckerberg's feed to be more favorable to AI, right? I
Yeah,
mean,
I what to say about that? I think that there's a lot of assumptions in that would have to be true
yeah,
for that to be the case. Um, I also don't work on those particular systems, so I'm not an expert on these specific ones. I think from what I've seen in my career overall on like what the kinds of machine learning systems or AI systems that tend to get deployed because they're useful to a company or to a service and ultimately to a user, they tend to be quite specialized, and there tend to be a lot of them. And so what you tend to have in a company is for a specific task, you'll have like an AI or an ML model or even just a simple statistical model to do a thing. And you want that model to do the thing it does as well as possible. There's a very interesting area of machine learning called multitask machine learning, MTML, where you kind of try and co-train a model to do more than one thing at once because tasks are somewhat related. For example, you might have a reinforcement learning model inside your robot for like picking up and moving blocks. And that might also teach it to do things like some skills which are useful in, say, construction. And so when you wanted to, say, create a new robot for construction, you wouldn't necessarily start from scratch. You would take some part of that model and just like add on to it.
I
And
see.
so it sort of starts to become modular.
I see.
Now, I guess where your question was going on the technical side was, could you end up with an AI that sort of has this very far-reaching multitask thing it can do to obtain some objective?
Right.
I think possibly yes, but it would need so much data and it would need so much careful training and tuning to do that, that I think it would have to be built quite deliberately, at least using today's techniques, as far as I understand them. And so I think we're pretty far away from that. But I think from a technical perspective, and maybe to kind of guide it in a more academic direction, multitask machine learning is a super cool thing to research. I think especially for you folks in the robotics interest.
All right. So I guess what fields of studies got you into AI? Because it wasn't you
Yeah.
didn't start with AI, right? So
Oh.
where'd you start with university, and how'd you end up at I guess
Yeah.
computer science and AI?
So I've had a bit of a varied path. I started off in physics. I got a scholarship to go to university from this nuclear energy company. And they were like, for every year that we pay for your studies, you have to work for us. So I was like, sweet, great. And then I interned there in the summer. And I just took a bunch of, so I don't know if it works like this in the US, but in South Africa, your degree is modular. You pick a major and then you pick courses. And as long as you do enough math classes, you get a math degree, but you do whatever else you want as well. And so you
Right.
could do math and biology, or you could do math and computer science, or whatever. And so I kind of had this mix. I took a bunch of computer science classes, and I stopped doing them in second year of university. I think what you guys would call sophomore, because it was too much work. There was so much homework. so much coding homework. And I was like, ugh. And so I stuck with math because it wasn't that much homework and I wanted more time to party with my friends. Horrible career advice, or is it?
No, tell me about it. I've literally no, like I'm no joke. I got what 3 college admits today, and I was like, which one has the best party scene? That was my decision making process. It wasn't which one had the best academics. First one was party scene. But yeah, I get that.
So yeah, and so math just turned out to be the one that kind of, I think there's like a bit of an aptitude thing there as well. Like I guess if I was a more naturally talented programmer, then maybe I would have found computer science easier. But the homework took me a long time. And so I kept in touch with the physics stuff because I didn't want to just do math for math's sake. And then, long story, but eventually this nuclear reactor research program got shut down, ran out of money. And so I worked at a record store and I was in a punk band for a while. And then MP3s kind of came along and killed the record store. This was before the world of Spotify and Tidal and all those things.
Yeah.
And then, yeah, I went over to the UK and I got into a program which was called analysis. And it was super interesting because it was focused on this idea of multiple disciplinary like academic fields, but you focus on a problem. And so the first problem I focused on was actually in fluid dynamics. It was about how does air flow over a wing, like the very tip of the wing, it forms these vortices. And if too many of them form when too many planes take off, they're invisible. But then when the next plane takes off, it could go through a vortex and it could flip the plane over. And so you want to get rid of these vortices, and how do you do that? And so there, it was really this intersection of math and computer science, where it was like, how do you build a simulation for this aircraft wing to understand these phenomena, and then do the math to figure out how to avoid it? And the next project, and this is, I'm getting to the point. Sorry, I ramble a lot. The next project was on image reconstruction. And so this is the idea that you have some image and there's a part of it that's missing. Say it's a famous artwork or something, and you want to fill it in. And the math behind this is a lot of matrix algebra and calculus. And so I did this. And then I was reading some papers on it because it was grad school. You know, usually they just give you a paper and say, hey, can you figure this out? And the paper said, hey, this is machine learning. I was like, what's a machine learning? But I was really coming at it from sort of differential equations and calculus and algebra. And someone had just, this paper that I read said was from a machine learning journal. And then I discovered these other labs at Cambridge. Turns out there were some very famous people working on machine learning there. I had no idea who they were until I took a couple classes from them. And so in the end, one of them was Zubin Giramani, who was the head of AI at Uber for a while. I'm not too sure what he's up to now. And so I started learning machine learning. And then the real kicker came for me when around 2012, 2013, sort of the recruitment folks come to the university. This is another fun thing that happens at universities. Recruiters from companies come and they'd like try and get you to apply. And up until 2012 in the math department, it was largely like hedge funds or like finance companies who were like trying to recruit math PhDs. But then all of a sudden, Google, Facebook, a bunch of other tech companies started showing up. And they were like, hey, we need people who can code, just kind of code, not like crazy code. You're not an engineer, but you know your math. And so you can understand data, you can model systems, you can run simulations, maybe you can do machine learning. And that at the time was what people were starting to call data science. And I just happened to be around when that happened. And I was like, this sounds great. I get to like write a little bit of code, think about hard problems and apply like math and, physical things I learned in physics to those problems. And it's really more of like a problem solving focused discipline rather than a, hey, build a big system at scale thing, which appealed to me much more. And so I really kind of stumbled into it. So I guess the advice I would extract from this is, when you're at university, stumble around. It's a very good time to not be too stuck into one field of study, and sort of like explore the adjacent areas, take classes in them, hang out with the people, find out who the professors are who might be famous in a field you've never heard of. And yeah, it worked out really well for me. I'm friends with a lot of those guys now, and have done a bunch of cool stuff with them, because a lot of them also left the academic world and went to these big companies and went on to do really cool stuff.
Yeah. I mean, that sounds really cool. And also, so like, what point did you realize that like the dots had connected? Because like you went from CS and like learning like C programming to math to physics, back to CS, and then like data, and then like it kind of merged to data science for you. So when did you realize that?
Um, you know, I don't know. I think these things are all connected. There's some fundamentals, and so maybe this is like another point that I think is you're never going to go wrong with focusing on learning the fundamentals. If I think about my first year of university, you learn things like Newton's method. You learn things like multivariate calculus. You learn things like matrix algebra, and it's those fundamentals that if you get those really solid, it becomes kind of easy to jump into whatever other field you might get interested in. Except for biology. I can't wrap my head around it. I still don't know how DNA works. My wife has tried to explain it to me like 10 times. I just don't get it. My brain doesn't work that way. And so I think of what I do now as, really a combination of problem solving with math and knowing what the right toolkit is. And sort of computer science, physics, math, all of these things have sort of the same fundamentals. That's me and my personal kind of preference. I have a lot of colleagues and friends who are like super deep experts on like one area in particular, and they live for it and they're like world experts on it. And that's amazing. I have so much respect for those people. I'm not one of them. And maybe that's also a good thing, is like I think sometimes we in our society, especially in our culture in the academic world and especially in STEM, we celebrate these like experts, and we should. But there's also these kind of like people who stumble around and touch different bits of stuff, and that can be a fun path too, and a productive one. And so I'd just maybe encourage you guys to explore that way.
Yeah. We actually had very similar advice from a previous speaker that was talking about exactly what you were talking about, which is learn the fundamentals and then stumble around with those fundamentals because they apply almost universally. So, and your thing was what it was basically math. Math was the fundamentals for most of this, right?
Yeah. So for me, okay, let me be concrete. Math is a very broad thing to say. So what do I think is super useful? Calculus, super useful. Matrix algebra, super useful. Like vectors and matrix algebra, pretty much everything. Simulation, like being able to actually take like statistics, like fundamentals of probability. These kinds of questions where someone's like, I have 2 decks of cards. I shuffle them. What's the probability I pull out 2 diamonds in the first 5 drawers? Like that kind of stuff becomes super fundamental. And then the other thing is just being handy with computers. And so I started off with C. I was never very good at it. I did manage to crash a lot of computers with segmentation faults. And then I learned Python. And like life was just instantly better. I'm like, mostly the things I care about are doing math, and I'm not having to like write a whole bunch of code to do the math. It's just like, vector dot other vector, and I just get a matrix and like, okay, cool. Now I can actually think about the problem I'm trying to solve. And then hacking around just in sort of bash terminal, just understanding Linux and how it works and being able to just stick stuff together until you get something that works, and pull a library from here and like read a paper about that, go, wow, that's too complicated. I need something simpler. And sort of this, my neighbor, Rachel, she works at John Deere on their autonomous tractors. And she's what's called a systems engineer. And her job is just like pick up all these pieces of like complex systems that other people have built and make sure the whole thing works.
Right.
I think like I'm not Rachel. She's much better at that. Obviously, that's her job. But my point here is like being able to piece together systems. Like to me, that's the fundamental from computer science. So a bit of Python here, a little bit of bash script over there, If it really needs some C code, okay, fine. Like I'm gonna struggle, but I'll get there. Yeah, sorry, that was a rambly answer. Was that you?
I kind of get it. I think, but so one thing that I've always like really, because I know different programming languages are applicable in different scenarios and are useful in different scenarios, but I still feel like fundamentally, because I've had my feet in the water in a few of them, and I feel like fundamentally, and maybe this goes back to what you were talking about, just like learn the basics, learn the fundamentals, and you'll have an easy time understanding most things. Is that they share a lot in common, right? And
Yeah,
so, here's a bit of a fun question: where would you recommend getting started if someone knows in this call knows zero programming? Which
right.
language would you have them learn first?
Oh, so actually, I'm gonna reject the premise of the question.
Okay, so
And yeah, so here's what I'd say. If you wanted to learn programming, don't learn a programming language. Think of an app or a problem you want to solve, and just try it and like Google around a little bit, go on Stack Overflow and look at the topic of the problem you're trying to solve and see what language people are using. Like if it's a web app, people are probably using, PHP or JavaScript or something like that. If it's something in sort of robotics, people are probably using, I would guess, Python these days. I wouldn't really know.
right.
If it's math related, it's almost certainly Python. If it's stats, it might be R. If it's systems, it might be Java or Rust. And then just like pick up enough of the language to do that. That would be my approach.
I'll actually go ahead and reject my own premise on this one
Yeah.
because you're absolutely right, and I have a few examples of this. So as a team, we work on a lot of projects outside of just a robot, right? And so one app that I spent a lot of time on was this scouting app called Team Track FTC Scouting. Anyone in the call, download now. But I didn't have a programming language in mind. I didn't even have a necessarily like I didn't have a language in mind. I just had an idea in mind, which is what you so beautifully pointed out. And that brought me on this whole like rabbit hole of like, okay, so this is how you make app. This is like how you do app development. And here's this useful tool called Flutter, and here's this useful tool called Google Cloud and Firebase, and then here's this thing called Cloud Functions, and then like it just led to this whole like uh web of things that you could do that I didn't know before. And it just the idea brought me there. Like if you just follow the idea, then you'll find your way stumbling into these other cool concepts. So
Yeah,
great advice,
100%.
actually.
Yeah, 100%. I think to take that idea even further, in my experience, what has tended to happen, there's a few branches that this kind of path goes. So you have this problem you care about, and either you realize, oh wow, someone solved that, and like here is a library, sweet, I'm done, I've solved this problem, and like now I can either think about what's the next problem, like how do I build on this, or you find one of two things. One, oh damn, I don't have the fundamentals to understand this at all. Like you stumble into something like Haskell. What's a monad? What is a functor? It's like all this like really abstract computer science stuff. And then you have to go learn. Okay, it's very unlikely you have to get into monads and functors for most problems. But or what you find is, okay, cool, I've got the fundamentals, but no one's written this. Like there is no like off the shelf solution. And I think at this point I should probably give a shout out to the open source community. When I was first learning to code and to like think about problems, there was just all this open source code around. This was before Git really existed, or before GitHub existed at least. I think Git existed.
So wait, then where did you find open source code from?
So there were forums, and you could use Git, but it was just people talking about stuff. But it wasn't just like the social aspect around Git, which is like GitHub,
Yeah.
didn't exist. And again, the reason it exists is someone was like, we need something like this because open source coding is like a social experience in a sense.
Yeah, it is. I mean, okay, to this day, I still don't get why people use GitHub as like a social networking platform. I don't get it. I really don't. It's like I just store my like this is where my stuff goes. This is like I just put stuff on there. Like okay, I guess I can make it a portfolio like one day, but like for now it's just throw it on there and like give someone a link. But no, you're right about like open source being a very useful tool for people to learn programming. I think it's very useful in robotics, especially because I walked in not knowing anything about anything. Like it was like, you know, like to get a robot to move from point A to point B, and then just making that motion more and more accurate and making it more and more complex, adding in like spline trajectories and having it like do actions while it's moving and stuff like that. Um, it's very helpful to have code to look at, like to know what to kind of do before you do it. Um, and then it becomes even more helpful to know then what did the open source code get wrong, because there's always something wrong with
Mhm.
a project. And I think recently, like I'm not going to drop in names because it's probably like meaningless in this particular conversation, but I found this like glaring issue with this piece of open source code. um and I was only able to recognize that as an issue because I had other open source code to look at and see, okay, this is how this stuff generally works, and here's an outlier, let's go ahead and fix it. And so um on
Yeah.
on our own robot, it's working great, and we've helped like 5 other teams fix this issue, which I think, you know, more power to open source.
The system works.
Right.
Yeah, this is huge. I'm reading this book at the moment that I'm loving, by Tim O'Reilly. It's called WTF, stands for What is the Future?
Oh,
Um,
okay.
and it's great. And Tim O'Reilly was one of the people who popularized open source as like a business model. And when I was a teenager, Microsoft was this big evil corporation. Everyone was like, "Oh, Linux is going to take them down," and like everyone was like, "But how? Like, how's that ever going to make money? Because it's all free." Um, and Yeah, it turned out not to be true. Like I think Red Hat I think they got acquired by IBM a couple of years ago for a couple $1 billion because it's the service, right? It's exactly this. And so people who have the expertise to build something on top of open source and keep it running at scale reliably and fix the bugs, that's how you got hired into Red Hat. You had to contribute enough to Linux, and
Right.
they'd be
Yeah.
like, "Oh, you know enough about the system. Do you
Right.
want to work for us?"
Right.
And it turns out that those open source systems are what runs the internet. AWS and all of that other stuff is built on top of open source software.
And they grow really fast too. I mean, like just take like, let's go back to the app development example. All the
Sure.
frameworks used for app development, at least on like large scale, not like, maybe not for bigger companies because I know they'll probably use native code, but like let's say you're doing a startup, like React is entirely open source, Flutter is entirely open source, right? So just I think it has very high potential to grow fast, which is I think what makes it compelling.
Yeah, I mean, it's funny you mentioned React. It's I think largely developed at Facebook,
Yeah, a Facebook
Meta,
product. Yes.
and it's open source. And the same
Yes.
thing is true with PyTorch, which is a machine learning library that a lot of people use it because it just works in Python. Um, and yeah, it's exactly that. And so I think it's really great that big companies now are also kind of they use open source, but also contribute to it, and it can become its own community around the way you build.
Right.
It's kind of fascinating. This would have been unimaginable in the early 1990s. People were like, "No, you like
You
software is a
keep your
thing
code
you
private.
sell."
Yes.
Yeah,
Right.
and
Um,
so yeah, I mean that was just within my lifetime, and so who knows what the software development world will look like in in the rest, as in the next 20 years.
yeah, I think it was a culture change though. I don't know if it was necessarily a like people just found the optimal way to like have like the growth maximized, or the growth of a product maximized. I think it was just like the culture, like Silicon Valley culture had changed.
Right.
And it was like, let's move from I don't know who changed it though. That's the thing. I just feel like the culture changed from like closed source development to open source development. Um
Yeah, there's a lot of books on this topic, and it is interesting. But I agree with you; it's a culture change. Um, these things are really hard to predict.
so let's take a step back and talk a little bit
Sure.
about your like career. Like where have you worked?
Yeah. So after while I was finishing up my PhD, I worked at this a company called Darktrace. I think it's a unicorn now. It was like a cybersecurity company, and I was really like a software developer there. Um, Not what I was best at. I think what I learned about myself there was I talk too much to be like a good full-time programmer. And so there's the spectrum of in your career how much time you spend doing just technical work by yourself, all the way through to like how much collaboration and just sort of talking work and planning work you do. and there's value along all those steps. So there's product management, I think, is something that a lot of people coming out of technical backgrounds don't really think about, but a lot of people end up in those positions in their careers. And that's like leading a product. It's like being the CEO of a product. So in my career, so I was at Darktrace, and then I moved to ARM. ARM has a very soft place in my heart. It's based in Cambridge, in the UK, which is where I studied. And it again had a revolutionary model. The idea was, we're going to design microchips. We're not going to build them. Like, there's an industry out there of people who want to build a certain microchip for whatever it is they want to build. And we'll just design these low power chips and license that intellectual property. And then you go and build your chip. And if you sell 1 million of them, you owe us 1 cent per chip that you sold. And it was this like community model, right? But for hardware. With proprietary though, like the intellectual property was still proprietary.
Right. Yeah.
And there is a notion of that still in open source software.
Yeah. No. Yeah. There is. Yes,
yeah.
I've seen.
And so yeah, always check the license. Maybe that's like a good piece of advice. Whenever you're writing code, check the license. Don't do things that the license doesn't allow. And yeah, ARM was great. It was a company that really invested in its people, and I learned a ton there. So I was the first data scientist there. Was a bunch of hardware guys. They were like, what even is data science? And that was kind of challenging, but I loved it because, you know, it was sort of like hard problems, and no one really had the toolkit that I had, because they just came from a different discipline. And so it was really collaborative. And I think we all, like, I learned a lot. My colleagues learned a lot from me. And we did some cool stuff. Like, we helped reduce fraud, where like people, because like I was saying, there's like a trust model where you're saying, hey, I'm trusting you to tell me how many chips you've sold. But like, how do you know that's true? And so we applied some very simple machine learning to predict how much people should be selling and were they being honest with us. And then we did a bunch of stuff around testing. When you design chips, you want to test them a lot when you're still designing them, because once you send them to the factory and you produce 1 billion of them, if there's a bug in that hardware, it's really expensive to fix, because now you have to change all the compilers on top of that hardware to like fix the hardware bug. Yeah, that was ARM. And then from ARM, I moved to Meta, but let's maybe pause there before I kind of go into that.
Yeah, wait, I had a few questions about,
Sure.
So you said you use machine learning to predict the revenue of the companies that these chips were sold to. What were like the inputs on that? How would you actually like based on what, I guess, would you predict that?
So there's some sort of like internal proprietary knowledge here I shouldn't really mention too much.
Okay, then sorry.
But I can give you the broad strokes.
Sure.
The broad strokes is, you know, the industry that a company is in. Say it's mobile phones, and you know how many mobile phones have been sold because that company is a publicly traded company. And so you look just in their, they have to report quarterly to Wall Street, we sold this many phones. And some other company that's selling calculators, electronic calculators, and you know how many they're selling, and you know what the selling price of those is. And you know their bill of materials, you know what chips they have in them. And then you look at their revenue, and then you look at what they paid you. And you do this for, you know, a couple of thousand different companies. That's your sort of training data. And then you look historically how much they had paid you. You make an assumption that they haven't always been underpaying you. And then you go, hey, like, did you guys like miss your growth targets? Like, it looked like what you told Wall Street was X.
I see.
But you know, what we're seeing is Y. Like, what's the reason for the gap? And the you know, you could have done this by hand. A human could have done this for like a few very big customers. That's actually what used to happen. We'd have like these audit specialists who would sit and look at the bill of materials, and then they'd phone up various companies, and we just automated a lot of that.
Yeah.
Because where it got tricky was, you know, there's some company and you're kind of accusing them of like not being honest, but at the same time you're trying to have a sales relationship with them. Hey, buy more stuff from us.
You don't want to break the trust like that, right? Yeah.
Right. And so what was so great about this approach was that we didn't say, hey, you guys are being like, you know, like assholes. We were like, hey, like our machine learning models think like you're not doing that well in the market.
Yes. Blame the model.
Can you guys like tell us what's up? Like, do you need help? Do you want to buy some more stuff?
Yeah. And
that worked great. The checks just came rolling in. The machine learning was very simple. It was like a very simple, like random forest model. So yeah, that was ARM. And then the more interesting stuff we did there was like making machine, I think for robotics crew, suppose your robot is out in a forest, and it's, you know, clearing stones out of the way so that a big tractor can come through and like not get stuck. You want that robot to be able to do its machine learning and gathering its data on the device. You don't want that to have to send data back to the cloud because it's in the middle of a forest.
Right.
And so making all of that machine learning stuff work on smaller devices was a big part of what I worked on at ARM. And it's hard because there's actually very few people in the world who know about machine learning and who know about like small devices. Like, and by small devices, I mean like a tiny sensor, like a thing that you'd have in like a keychain.
Right. Yeah.
And so there's like a whole community around that, a bunch of startups doing that now. It's really exciting.
Tiny machine learning.
Yeah, like on-device machine learning for privacy reasons too, right?
I mean, it makes sense to do it. Yeah. And there are some applications where this is like TensorFlow Lite is one example, right? Yeah.
Yeah. So that's Pete Warden and his crew. Yeah, we were, great guys. Yeah. So yes, 100% agree. And so that was interesting at ARM. And then, you know, I'm not a hardware guy. I know very little about hardware. And so an ARM had been acquired by a company called Softbank, which was great. It's always awesome when your company gets acquired. That's the Silicon Valley way. And then I was like, well, what problems do I want to solve next? And I'm sure I don't have to tell you that there's a lot of problems in the world that Facebook, for, you know, rightfully or wrongfully, gets in the middle of. And yeah, so it's why I joined Facebook. And mostly what I've been working on is how do you make registration and login flows for users? This is really now about like products, like internet products.
Yeah.
How do you make that easy for people, but safe? So for example, in countries like South Africa or India, a lot of people are coming onto the internet for the first time. They have no idea what an account is, what a password is.
Right.
And so you want to help them. But every time you help them, you also make it easier for a hacker to attack their account. And so you have to be really intentional about how you design these systems and how do you gather data to know that they aren't being exploited. Yeah, that's what I've been working on. And now metaverse, which is kind of a new thing. We're all trying to figure out what it means. And so yeah, some exciting stuff we're working on, and that's what I've been working on over the last couple of months since it was announced.
So you're working on something different, like it's no longer the registration stuff, or is it still the registration stuff on Meta?
You know, the way things tend to go in like on a career path is that if things are going well, your scope kind of expands.
Right.
So you know, I'm very lucky that I have a team of people who are amazing at what they do, and so they report to me, and I've got a few people who work on that kind of security stuff for the registration and login page. And then I have some other people working on the metaverse stuff. And so where I pay a lot of attention is sort of to the big problems. And then I'm lucky enough to have a really strong team who I can say, this is a problem for that person. And then they can kind of go.
So wait, this is like the perfect example of like going from like absolute like low level bone code to like upper level management code kind of thing, right? So describe, I actually, am I allowed to ask this question? Describe a day in the job.
Sure. Yeah.
Okay,
100%. I can tell you about today. I'll even look at my calendar. I'll be super honest with you.
Okay.
What did I do today? So today started with a review on the number of accounts that get hacked. And I wouldn't tell you the numbers. And then, so we had a review with a bunch of senior leadership at the company and like trying to figure out what our strategy should be, because accounts do get hacked. I'm not going to pretend that they don't. And how do we what's our next set of solutions? Because it's adversarial, you know, like you make a change to the system and then the attackers change their behavior. It's the
right.
sort of like arms race. And so then after that, I went into a review on WhatsApp on some new products we're launching and like what the launch strategy would be. I won't talk about what the products were. Then I went into a presentation that I gave to some of the people who are designing some of the new features we're building for Metaverse, where I presented some of the data that my team had on some existing products to say, hey, designers, these are people who kind of like, they're almost like computer game designers. They like design the actual interaction, but they don't write the code. And saying, hey, like, let's try and design a product that does this, but not that, because people like this, but not that. And so, yeah. And then after that, I interviewed someone for a job. Then I had 3 one-to-one meetings with sort of my peers from across the company. So a guy who works on Messenger, then another guy who's a data engineer. And then I had a rehearsal with a speaking coach for an all hands we're doing for the a large part of the company, all the data scientists in the company. We're talking a little bit about some of my team's work. Then I actually did some work for 2 or 3 hours. I had like no meetings. And yeah, and then I did some performance reviews, finalizing the performance reviews for my team. That's happening next week. So yeah, and now I'm hanging out with you guys.
Yes, and thank you for being here. But so do you program at like on the job?
Very little.
That's nice.
Yeah, so I've been doing this now for what year is it? It's 2022. Yeah, I've been in the industry for like 8 years now, and I started off as like an individual person who writes code. And I've been in management now for maybe 6 years. Having folks who report to me, and the amount of code that I write has sort of been steadily decreasing.
Right. Yeah.
As you I would generally say once you have like 4 or 5 people reporting to you, it becomes very hard to write code. Some of my colleagues still do it. Like I said at the beginning, I'm not a very good programmer. I'll write code if I need to. Actually, the last thing I wrote code for was a card shuffling script, just a Python notebook, because we couldn't find a deck of cards and my wife needed it for a party game for like a Christmas party we were having. And she's like, can you just like write a card shuffler? And I was like, I guess so. It took 5 minutes, but yeah, that was the last time I wrote code.
Huh. All right. Cool, I guess. So okay, I'm gonna move to ending questions.
Sure.
What advice would you give to your high school self?
Yeah. I think I've just given a lot of the advice, to you folk directly. I think I would have liked to be a stronger programmer. I think when it got hard, I kind of like pieced out of it. I was like, oh, okay, I can code enough. I don't need to like learn much more of this. And then I think the major thing we already touched on, you and I had that, a good back and forth on this, on the focusing on problems and trying to solve them rather than just trying to learn things for book learning. I think throughout my academic career, I would get interested in concepts, and I would like read a textbook on a topic and like get really familiar with the abstract theory of it and never use that knowledge, or like never actually have a problem in mind. And so maybe I'm a little bit hypocritical in that way. But if I look back on things that were actually successful, it was when I didn't take that approach. So since I've rambled so much, I'm going to be succinct. I'm going to say that's the thing. That's the thing. Focus on problems and try and solve them.
And that's, I think, a good note to wrap up this episode of the Cuttlecast. So thank you, Damon, for joining us. This was an excellent conversation. A lot of insightful topics were covered. Rashil,
Awesome.
do you want to?
Thanks for having me. It was really fun to hang out.